Hey everybody, welcome back to my channel. This is WireDogSec back with another video for you guys. Today's video we are in TryHackMe. This is the SOC Level 1 Legacy pathway, and this is the Digital Forensics and Incident Response module. This is the critical room. Acquire the basic skills to analyze a memory dump in a practical scenario. Hopefully you all are excited and ready to learn something today. Before we dive into it, if you want to help support the channel, be sure to like, comment, share, subscribe, and hit that notification bell so you know every time I upload to the channel. Without further delay, let's go ahead and dive into it. Task 1 Introduction. Incident Scenario. Our user Hattori has reported strange behavior on his computer and realized that some PDF files have been encrypted, including a critical document to the company named important_document.pdf. He decided to report it. Since it was suspected that some credentials might have been stolen, the DFIR team has been involved and has captured some evidence. Join the team to investigate and learn how to get information from a memory dump in a practical scenario. Learning objectives. In this room, we'll cover the following learning objectives: memory forensics, basic concepts, how to access and set up the environment, gathering information from the compromised target, search for suspicious activity using the information obtained, extracting and analyzing data from memory, conclusion and further steps after completing the room. In this room, we'll learn how to extract essential information artifacts from performing a memory forensic task in a compromised machine using the Windows operating system. First, we'll learn basic memory forensics concepts before setting up our working environment. Next, we'll learn how to get basic information about the compromised target and how to search for suspicious activity. Finally, we will extract interesting data that may help us identify potential malicious actors. Learning prerequisites and understanding of the following topics is recommended before starting the room. So you have analyzing volatile memory, volatility, IR difficulties and challenges. So be sure to check this out beforehand. Even check out my channel to see if I have videos over these. So we're done with this task. Task number 2, memory forensics. Let's now recap some important concepts about memory forensics that may be useful for us while working on the scenario we are presented with. In cybersecurity, memory forensics is a subset of computer forensics that analyzes volatile memory, usually on a compromised machine. In the Windows OS, it corresponds to the random access memory, or RAM, and its content is flushed with every reboot or shutdown, making it one of the usual initial tasks to perform during incident. The process differs from disk forensic analysis since it not only provides information about what resides on the target computer, but also provides us with information about the processes or applications that were running at a particular time and detailed information on the execution flow of a system or on a system that may not be present in the in regular storage units or application logs. This memory analysis can help us with an immediate snapshot of an application's or a timestamp of an attacker's actions. This is crucial since evidence collected through memory forensics can become invaluable in creating a chronology of events, so basically a timeline of events. We can divide the task in a memory forensic task into two main phases. You got memory acquisition and memory analysis. During the memory acquisition phase, we'll copy the live memory to a file and commonly referred to as a dump to perform the analysis without risking losing the data from an inadvertent reboot on the compromised system, and have proof of the analysis ink as needed. Sweet. Okay, so here's a picture of that, acquiring it, and then there's a dump there, and you're going to take that to a lab and start doing the analysis on it. Next, during the memory analysis phase, we'll analyze the obtained memory dump of the forensic data suite. Okay, so question time. What type of memory is analyzed during a forensic memory task? Well, you know that's going to be RAM, random access memory. Uh, let's see here. In which phase will you create a memory dump of the target system? So when you're creating that dump, that should be the memory acquisition phase here. So let's go ahead and copy that. All right, task number 3, environment and setup. I've already clicked the button here to start the machine, as you can see there. Using knowledge from our previous task, we can approach the first phase of our memory forensic task, memory acquisition, and determine the environment and tools we will use to analyze the memory dump. Imaging tools. There are several ways to acquire the memory from the target machine if needed. Several tools can help us, but which one to use will depend on personal preference and operating system involved in the imaging task. Some of the tools are for Windows, you got FTK Imager and WinPmem. Linux, you got Lime, and then Mac OS, you have OS X PMem. In our scenario, FTK Imager was used to take the memory dump of the compromised machine, which was copied to the Linux machine to perform the analysis, accessing the machine. Before moving forward, start the lab by clicking the Start Machine button. Take around 2 minutes to properly. You can access the machine split through, which we're doing here. You can access it via SSH using these credentials there. A memory dump name, memdump.mem, will be present at the home address here. So in home analyst, okay, that's good to know there. And let's just go ahead and clear the screen here. All right, we're already there. So that's good to know there. And there's volatility right there. A memory dump name, memdump. Okay, we already read that. To analyze the analyze the dump, we'll use volatility 3, a popular choice among analysts to inspect a memory during an incident. In this case, the tool has been installed and an alias was created for simplicity. Entering the command vol will execute volatility 3 in the terminal. The -H switch can display the help menu as shown below. So we can do vol-H, okay, to pull that information up there. As we can observe from the above output, volatility gives us several options to analyze the memory. We can list a plugin specific for each OS. Since in our case we are analyzing a memory dump from Windows, let's list the Windows plugins, executing volatility using the Windows keyword as an argument to search for Windows plugins, using the --help switch to list them as shown below. All right, so if we're just following along here, we'll just up arrow there, and then we'll type in Windows --help. I'll pull back all those modules there. Okay. Plugins are extremely helpful during the analysis when using Volatility 3, since they quickly parse a memory dump for specific data types and sort the data according to the selected plugin. You can find a summary of some of the most relevant plugins below. Okay, here's a big list of them. I'm just going to read a few of them. So you got Windows.cmd line or command line list process command line arguments. Windows.driver module determines if any loaded drivers were hidden by rootkit. Windows.file scan scans for file objects present in particular Windows memory image. You have Windows.gsids print the SIDs owning each process. You got Windows.handles, .info, .nets scan, .netstat, .mftscan, .plist, .pstree. Now that we know how to access our environment and which tools we will use, let's move to the next phase where we'll start analyzing the data. All right, so let's go and take a look at these questions here. Which plugin can help us get information about the operating system running on the target machine? So if we go back up here and look, we can see if we can find that information here. Let's see here. Okay, so info is probably what we're needing here. Let's plug that in. Sweet. Okay, which tool referenced above can help us make a memory dump on the Linux OS? So let's go back up where they mention those tools. It should be Lime. It's going to be our answer there, all capitalized. So Lime. Which command will display the help menu using volatility on the target machine? Okay. And that was using the alias, so vol and then -H. That's what they're looking for here, I'm pretty sure. Yep. All right, so task number 4, gathering target information. All right, so let's take a look at this real quick. Getting information about the target is crucial to our investigation since it ensures we're analyzing the correct context and environment of the evidence. This step helps us understand specific architecture and operating systems, ensuring our findings, accuracy, relevance, and legitimacy. We can get information about the target using the -F switch to indicate the file to analyze, in this case mem.mem, followed by the plugin windows.info used to get the general information as in the example. So I'm just going to copy and paste here, clear all this out, paste if it lets me. There we go. All right, so we should have terminal output here as it runs through everything. Okay, it's a lot of information to take in. The output above shows relevant information to identify the machine we are working on, such as architecture, number of processors, and version. All this can help us correlate information and data with our analysis performed on separate hardware of the compromised machine or the network itself, while still having proof this is the machine that was compromised. With this taken into consideration, navigate to the working directory in the VM and execute the command vol dash f mem dump.mem windows.info, which we already have there running, to answer the questions below. So once this finishes running, be sure to answer the question yourself, then come back to the video, and then we will continue on. I'm not sure how long this is going to take. As you can see, it's already taken a while as we fired this off earlier. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos that you can see here, over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking, enjoy the video. Okay, it's finally done. As you can see there, so I'm gonna scroll down to the bottom here so we can start answering some of these questions. Is the architecture of the machine x64 or 64-bit? Yes or no? That's going to be a yes. So if we take a look here where it says is 64-bit, it's set to true. So there we go there. What is the version of the Windows OS? So on this one, you can see the version is going to be 10. So NT major version is what I used here. And the last one, what is the base address of the kernel? And that's going to be at the top here, where it says kernel base. And then you're going to grab this long value here and plug that in. So we're done with there. Task number 5, searching for suspicious activity. Now that we have the information from the target we are working on, let's try to identify any suspicious activity in the memory dump. Suspicious activity. Suspicious activity refers to technical anomalies that may be present in a system, such as unexpected processes, unusual network connections, or registry modifications. These activities often signal potential security threats like malware attacks or data breaches. Starting the search. We can start by observing any potential network activity. We can use the plugin windows.net stat to see if there's an interesting or unusual connection. At this stage, remote access connections or access to suspicious sites are something to look for. Let's navigate to Home, Analysts, Directory, and execute the command here. So I'm going to run this plugin here, this windows.net stat. So let's go ahead and clear all this out. Hopefully this doesn't take forever to run. Once it's finished, okay, so we already have a lot of information here. Sweet. So we know it works. All right, so we have similar information here, right? So we got local ports, IP addresses. You can see the columns and names and stuff up here, right? To reference the information down there. Says from the output above, we can observe a connection established on port 3389. Okay, 3389 from the IP, this .139 with this timestamp. This could indicate an attacker's initial access. And now that we have information about the network, let's look at the processes. A volatility plugin we can use is Windows.pstree, which will display a tree of the processes running or running on the OS. So let's go ahead and copy and paste this plugin here, which is going to be Windows.pstree. So let's clear this out and fire this off. Okay. Sweet, a lot of information there that could be useful. And we should see something like this as we're going through and trying to identify suspicious activity inside of here. As you see there, they already have it pretty much highlighted there. Let's see. As we can observe from the above output, the command provides us with the information on processes hierarchy running on the system, indicating to us the process and their retrospective parent process. In this case, services.exe is the parent process of DLL host. We can see that here. All right, so we have 636 as the PID, and that's the parent process ID of DLL host.exe, okay? But how can we identify this process? One of the most common ways is to check the name of the process. Directors commonly use names to try to disguise the execution. One of the ways to do this is to check that the process is not usually present. We can find a list of processes or commonly used in Windows represented in the image below. So here we go right there. All right, so that's good information. Considering the above image, or considering the above and looking again at the output, we can observe a process with the truncated name critical underscore updat as shown below. Okay, very interesting there. This process did not look like it is part of the system and observing it in detail. It's the parent process of updater.exe, which is also not listed as a process part of the Windows OS. Great. We identify a possible malicious process and should note the information like timestamp, the PID and the PPID, and memory offset. Sweet. That's ideally what you'll do if you go through investigation. You'll check for things out of the ordinary or anomalies, as it was explained earlier. So you have to go and sift through and determine what is normal here. We can see what they're just talking about, updater, and then you get critical update right there. Okay. So anyway, looks like we have some questions here that need to be answered. So go ahead and try to work on those yourself, and then come out to the video, and then we'll step through it together. Should be able to get these as we just ran through these plugins and such. So good luck. Using the plugin, Windows.net scan, can you identify the destination IP address where a connection is established on port 80? All right, so we're going to be using this net scan plugin. All right, here, this is what I have here, vol-f, mem.mem, windows.net scan, pipe that into grep, look for established because that's the connections that we're looking for here. Then you're going to pipe that again and grep it on port 80 to try to slim this down. All right, so let it run, do its thing here, and I don't think this takes very long to run. So once it's finished, it'll give us that information. Okay, and just look at this next one here. Using the plugin Windows.net scan, can you identify the program or owner used to access through port 80? Okay, it says it's finished, but there's nothing there yet. Okay, it's still loading. Anyway, and the next one, we're going to have to use that PS tree plugin, right? Yeah, so we're going to use that PS tree plugin. It was referenced somewhere in this room here. To get this one in there, we're going to be looking at the PIDs and like PPIDs as well. So let's see if it's done. There we go. All right, so it's finally done running. There's the destination IP, right? Port 80 established, and then you can see Microsoft or MS-Edge.exe is going to be our answer there for this plugin here where it says the owner. Okay, and we know the destination IP is going to be this one here, this .128, as we saw there from the output, right? Okay, and next one here, let's go ahead and take a look at these PIDs. So let's go ahead and clear this out. I'm just going to up arrow, PS tree, hit enter, and we're going to get a lot of output back, but there's the critical up dat, okay? And the PIDs are on the left, and then the PPIDs are on the right, I believe. So let's scroll, make sure, yes, PID and the PPID. So let's scroll back down, take a look here, and we have 1648 as the PID for critical underscore updat. And if we look through here, that is the PP or the parent process ID right here, 1648 of this updater.exe. Okay, so and we need to find the actual child process on that for that. Okay, so we know that those two are connected through the PID of critical update, and then the PPID is going to be the same for this updater.exe, and then that PID of updater.exe is going to be the 1612, so that's going to be the child process that we need there. Okay, and next one is, what is the timestamp for the process with the truncated name critical underscore updat? So that's an easy one there. Just basically, scroll to the right side here and just grab everything here that's listed for critical updat. So make sure I grab the right one right there. So grab that, copy and paste that, and then there you go. Task number 6, finding interesting data. With the information we have collected, we can investigate the process critical underscore updat that we identified in our previous task, which has a child process called updater. Let's investigate the child process more in depth. Let's start by looking at where on the disk it was saved. For that, we can use the plugin Windows.FileScan, which will allow us to examine the files accessed that are stored in the memory dump. This output is quite big, so to access the data in a better way, we'll use the the greater than character in bash to redirect the output to a file. In this case, file scan underscore out. Okay, and that's what they're doing here, putting that output into that file. So it's good to know there. So I'm gonna copy and paste in case we need to do something with this. I'm gonna let it run because it said maybe it could take a while or have a lot of output there. So let's go ahead and do that here. Okay. So that's out of the way. After executing the command, we can expect the data by using the cat and filtering using the grep command shown below. So cat, their cat in the file, then piping that into grep, and then updater looking for things that display there. And then we should get an output like this here. Above, we can observe that the files have been stored in the directory users user01 documents update.exe or C users user1 or 01 documents update.exe. If we want to have more detailed information like when the file was accessed or modified, we can use the plugin .mftscan.mftscan, okay, whose output is also quite big. So we will redirect the output to the file mft underscore out. Okay, so same thing here, putting this into a file here to look at later on and sift through. It says it's finished, but let's just go ahead and run this as well, and then we'll take a look at these here in a second. We can then use grep again to parse the information or parse the file for the appearance of updated.exe, and that's how you do it here, pretty much similar to what we just saw up there, and she would get a output like this. From the output above, we observed the last 4 timestamps correspond with the created, modified, updated, and accessed timestamps. We can take notes of those. So a lot of good information here to take in. And let's flip back over here. It says it's done, but there's no prompt or anything there. So let's give it a couple more seconds there. We're going to talk about getting the goods for our next one. So this looks pretty lengthy here for this task. Here, a lot of information. Let's flip back over real quick. Still not done yet. There we go. Okay, so ls, and there's both of our files. So let's just take a look at both of them real quick using that cat. Okay, here's one of them here. Sweet, and take a quick look at the other one. Right there. Okay, let's go ahead and continue on here. Getting the goods. Let's get information on the process. There are several ways to examine memory, but we will continue using volatility. This time we'll dump the memory region corresponding to updater.exe and examine it. To accomplish the above, we'll use the plugin windows.mem map. This time we'll specify the output directory with the -o switch. In this case, we'll use the same directory denoted by the character dot and the option --dump followed by the option --pid in the PID of the process, which the case in this case of update.exe is okay, the 1612. Okay, let's go ahead and run this out. When the command above is finished, we will have a file with an extension called docdmp in our working directory. So let's go ahead and do that. Paste, let it run. Examining the file is difficult since it contains non-printable characters, so we'll be using strings command to analyze the output better. Since we have these file strings available to us now, we could look for key patterns like HTTP or key, or any pattern that could lead us quickly to an artifact. Another way to scroll the terminal is by using the strings command piped to less to navigate through the output as shown in the command output below. So they're using strings PID 16 or on that file, and then they're using less. You can also use more, and there's others out there you can do as well. Basically, just making it easier to read as you're scrolling through this information. Let's see if it's done. Okay, looks like it's still going, and it just finished. Cool. So let's see and check. There it is. And let's scroll back up real quick. And let's run strings on it with less. Okay, looks good to go there. There we go. See how easy this is? And then you can hit like spacebar to go quicker than that. But all right, so we get the gist of it. And let's see here. As we can observe, we immediately identified a possible key in a domain from a URL that the process may have accessed. Also, by scrolling down, we found more indications that this is a malicious process since we can find the important document.pdf file name indicating the interaction with the file. Sweet. We see that here. Great. We can infer that the process update.exe accessed the document important underscore document.pdf and accessed a key at some point with this URL here. If we use the command grep to look for HTTP requests that may be stored in memory, we can do it by using the -B and capital or -A to look for 10 lines above and below our match to see if we can spot something else. And this is how you do that here. So this is some good information to take in. All right. Scrolling up, we can observe the HTTP request is displayed. Okay. From the above, we cannot observe at the end of the HTTP request the content of the file and key.txt. And on the same request, we can observe data with the value cafe babe. This could be the key to encrypting the PDF used by the attacker that was not downloaded to disk. Awesome. Excellent. We collected valuable information from the memory dump, including the possible key used to encrypt the documents. So once again, pause the video and try to answer these questions yourself. You should be able to as we just step through this. But anyway, once you're done or get stuck, come back to the video and then we will continue on. Let's take a look here. Analyzing the Windows.filescan output. What is the full path and name of the critical underscore updat? All right, so we ran this earlier. Cat file scan underscore out. Then you're going to pipe that into grep and look for updater. And it's going to be this first one here. All right, so just throw in C colon, right? And then under C colon users, then user 01, et cetera, et cetera, et cetera. Okay, so that's how you get that one. And this next one, analyzing the Windows.mft_scan.mft_scan. What is the timestamp for the created date of important underscore document.pdf? Now you can do something similar as well. You just grep on it, right? Using that file. So cat mft_scan underscore out, pipe into grep important document. And I used the first one that was listed here. So I'll use this here as my answer there. Okay, so we are done with that one. And this last one here, analyzing the updater.exe memory output. Can you observe the HTTP request and determine the server used by the attacker? And we probably saw something like that earlier, right? So that's the last one we did from that dump file, if I'm not mistaken. So you can find it using this. Just hit enter, and then as it's going through, you'll see something referenced here called where it says server, and then this simple HTTP, et cetera, et cetera, et cetera. So that's the one we're going to be grabbing for that answer there. You see all kinds of information in there, by the way. So that's good to know there. Plug that in as our answer, and we are done. Task number 7, conclusion. In this scenario, we have put into practice the skills necessary to start digging into the world of memory forensics and practice with a tool like Volatile, which is widely used among digital forensic professionals. We learn how to gather information about the machine the dump belongs to, search for connections, enumerate and investigate processes, and examine the content for malicious patterns in a memory dump. While all the information presented in this room can be used in real-life scenarios, it is possible to delve more deeply into the topic by examining more complex attacks. Some interesting material to get more into it can be the following. So you have Windows Forensics 2, Linux Forensics, iOS Forensics, Windows Application Forensics. Be sure to check my channel for anything related to that could be of use there. And also check the description, see if I have any helpful resources to expand your knowledge. A lot of the stuff can be very useful. I'll have a link to this Medium article here or blog post, complete guide on how to identify a suspicious process that could probably come in handy. There's a lot of things to read through, 19-minute read, a lot of good information in here that could be useful in your career as you're going through and looking at things, or if you just want to look at it in like a lab environment or whatever. Okay, so we are done there. Let's go ahead and hit complete, wrap up this video. As usual, thank you all for taking the time to watch my video. If you want to help support the channel, be sure to like, comment, share, subscribe, and hit that notification bell so you know every time I post to the channel. Have a nice day, and I will see you in the next one.